All right, in this video, we are looking at graphing cubic functions. Okay, so there is a difference. So St. James heading, and then we'll get started. You want the St. James heading at the top, and obviously graphing cubic functions, underlined in red. Chapter 10, Section 4, there is no Section 3, or we're skipping Section 3, I should say. And this, of course, is Part 1. We'll just do a few more practices. So to review, we did quadratic functions that can be used to find the area of a square. And I say that now because we're used to quadratic functions having that squared component. So you recognize y equals x squared, that's a quadratic function. Well, it can be also used to find the area. Area equals s squared, or the side of a square, and then multiply by itself. So you could have y equals 2 squared, y equals 3 squared, y equals 4 squared, y equals 5 squared, and all those things would be able to find the area of a square. We can make those tables again, and you'd have those squares. Well, a cubic function is where a cubic function can be used to find the volume of a cube instead of the area of a square. So you'll see that its length, volume is, as you remember, length times width times height. And if we're talking about cube, then all of these things would be, meters times meters times meters, right? Or feet times feet times feet, or miles times miles times miles, or what have you. Well, that's really just something squared, because then you would have meters cubed, or not squared, yeah, cubed. So you'd have meters cubed. So you'll get y equals x cubed. So a cubic function has something to the x cubed, okay? And the cube, as you know, would have the same dimensions on all sides. Okay, yes, we are talking about three-dimensional figures, so you would have this square, and the way I draw it with one square on top of the other square, offset it a little bit, and then you get your cube. And they would all, if it was a true cube, then everything would be like 1 inch, maybe, or 1 meter by 1 meter by 1 meter, in which case this would have a volume of, well, 1 meter cubed, because it's 1 times 1 times 1. Okay, so that's a cubic function. And what we're going to do is we're going to learn how to graph cubic functions, just like we learned how to graph quadratic functions. Just we have to pay attention to our, I would say, our mathematics, and make sure we're doing everything correctly. So here we go. Again, I do want to start with a -2, -1, 0, 1, and 2. Okay, let's see what these cubic functions look like. I'm just going to play with the numbers, and I'll show you what a cubic function graphs and how it's graphed. Okay, so y equals -2 to the third power. So we have, that means it's -2 times -2, and then times -2. Okay, well, -2 times -2 is 4, times -2 gives us -8. Okay, so now we have y equals -1 cubed, or to the third power. So it's -1 times -1 times -1. And obviously we get -1 times -1 is 1 times -1 gives us, well, -1. Okay, and then we know y equals 0 cubed. Well, that's just 0. Anything times 0. 0 times 0 times 0 is 0. And then y equals 1 cubed. Well, that's 1 times 1 times 1. So that gives us 1. And then y equals 2 cubed. Well, that's 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8. Okay, I'm just going to fill this in because it looks weird to be blank. So that's a +8. All right, now we'll graph it. Let's see what it looks like. So we start going left 2 spaces, 1, 2, but then down 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's -2, and then -8. And then we go -1, -1, and then 0, 0, and then +1, +1, and then +2 to the right 2, and then up 8. So as you can see, this graph, a cubic function, graphs like that. Okay, it has 2 bends in it, whereas the quadratic function only had 1. Well, it had a u. an upward U or a lowercase u. This is more of like a snake or a backwards S, okay? But it's going to have some bends in it. So a quadratic function has a bend, and it should look like that, 99% of the time. Sometimes they're more steep than others, but that's what a cubic, that's what a cubic function looks like. Okay, it has a bend in it. So we're just going to practice graphing them. So we still do the same thing, just pay attention to your negatives. You have three negative numbers, -2 times -2 times -2, and what happens with those negative numbers, okay? So just be careful of that. All right, so here we go. Again, we have another example, y equals x cubed minus 1. So we start with -2, -1, 0, 1, and 2. That's going to be consistent throughout this whole chapter, okay? If you do -2, -1, 0, 1, and +2, okay? Just be consistent that way. So we have y equals -2 cubed minus 1. So again, it's -2 times -2 times -2 times -2. So we have -2 times -2 is 4, times -2 is 8, and then be careful, you have to remember to subtract the 1, and you get 7. Okay, and then we have y equals -1 cubed minus 1, so it's -1 times -1 times -1. So -1 times -1 is a +1 times -1 gives us, well, -1 minus 1 gives us -2. Okay, this is where you have to know your integers. I said that from the beginning. Know your integers. 0 cubed is 0, because 0 times 0 times 0. And then minus 1 gives you -1. And then y equals, I almost wrote negative. Y equals 1 cubed minus 1. So that's 1 times 1 times 1. So that's 1 times 1 gives you 1 minus 1 gives you 0. And then y equals 2 cubed minus 1. So that's 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Minus 1 is 7. Okay. So here's going to be a little bit trickier because there's not going to be as much as a pattern as you would have seen the first time. The first time with the quadratic function, you saw a pattern in the y's. You're going to be less likely to see a pattern, so just to make you aware of that. You didn't do anything wrong. Okay, so we have -2, negative, we go left 2 spaces, and up 7. 1, 2, 3, 4, 5, 6, 7. Okay, now we go left 1 space and down 2. Okay, down 2. 1, 2. Okay, and then we're at 0, -1. Okay, and then we're at +1, 0. And then we are at +2. Oh, I know what I did. Something is not right. Something is definitely not right. Okay, so I figured out where I went wrong, and I paused the video. I just wanted to recheck my work here, and I found my mistake. So you're probably screaming on your home going, "There's a mistake, sister." So here it is, right here. When I did 4 times -2, it should be -8, and -8 minus 1 is -9. So that's where that went wrong, which is why I was trying to figure out why my numbers were looking extremely funny. Okay, so this is why it's always good just to check the math, and I tell you, I have moments, you have moments, it's totally fine, and we just work through those moments. And again, you're still not going to see a huge pattern when it comes to quadratic formulas, so just to make you aware of that, okay? And I'm just double checking my math to make sure I didn't make any other obnoxious mistakes. I think we're okay. I know you guys will tell me if you see something, so that'll be fine. If you see something, you come in and let me know. Okay, but I think I got it figured out now. So we're at negative 2, and we need to go down 9 this time. So that's here. And then we're at negative 1. And then we're at negative 1, negative 2. And then we're at 0 and negative 1. And then 1 and 0, that's better. And then we're at 2, 1, 2, positive 2, up 7. 1, 2, 3, 4, 5, 6, 7. Okay? So you're going to see, here's this quadratic cubic formula, the cubic function. And this cubic function, again, is like that snake or winding road. Okay? And it's going to have little bends in it. And you just have to be careful of your math, okay? Just like I had to just watch. I just got to be careful of it, okay? So we'll take our time with this and make sure we don't have to rush. If it makes it a long video, it makes a long video, but it's better to be correct, okay? So let's try the next one. Again, it's going to have that bend in it, so if you don't really see the bend, then you probably did something wrong, just like I did. And that's when I started noticing with those dots. I was like, I'm not getting that bend. That is a classic cubic formula or cubic equation. Okay, so again, negative 2, negative 1, 0, 1, 2, and we're going to plug it in. So we have y equals negative, and then it's negative 2 cubed. Oh, nope, negative 4. I forgot to put the 4. Okay, so it's negative 4 times negative 2 cubed. So we're going to do negative 4, but you times it's negative 2 times negative 2 times negative 2, okay? So, again, negative 2 times negative 2 is 4 times negative 2. So we have negative 8, I remembered it this time, and that's times the 4, negative 4, which gives us a positive 32. So we're probably not going to graph the 32, because that's way off our grid. Okay, really far off our grid. But we can do the next one. Y equals negative 4 times negative 1 cubed, and we get negative 4 times negative 1 times negative 1 times negative 1, and we know that that is all negative 1 times negative 4. That gives us a positive 4. That we can graph on our grid a little bit easier. Okay, y equals negative 4 times 0 cubed. Well, anything times 0 is 0, so that's fast. Y equals negative 4 times 1 cubed. Here we have negative 4 times 1 times 1 times 1. So it's negative 4 times 1, which is negative 4. And then y equals negative 4 times 2 cubed. And you're going to see that here's a familiar pattern because there's no plus 4 or plus 2 or plus whatever. The pattern is there, and you'll see that we get negative 4 times a positive 8, which gives us a negative 32. So you see, it's just a negative 32. So you go positive 32, positive 4, 0, negative 4, negative 32. And we'll graph, obviously, the middle 3 numbers, or 3 coordinates, because we can't do 32. It'll be way off our graph. So let's look at negative 1. So we go left 1 space, and up 4, 1, 2, 3, 4. Okay, and then we're going to go 0, 0, and then we go right 1 space and down 4, 1, 2, 3, 4. And we know now that kind of the flavor of quadratic formulas that this 32 would be way up at negative 2, so way over here, and it's going to come down through the origin and go way down there. Okay, so there's that snake. It's a little bit more tame. It's not quite as squiggly, if that's scientific for you. Okay, but it's still there. Still there. Okay, let's try again. Again, we're just going to do one more example and then the problem for next class. So here we go. Start with our points, negative 2, negative 1, 0, 1, and 2. We're just plugging in the table and graphing. So we have y equals negative 2 cubed plus 4. Okay, so we have negative 2 times negative 2 times negative 2. We know that gives us negative 8 from my mistake before, because you have 4 times negative 2. And then you add 4 and you get negative 4. Next one, y equals negative 1 cubed plus 4. And you get negative 1 times negative 1 times negative 1. And that gives us a negative 1 plus 4. That gives us positive 3. And then y equals 0 cubed plus 4. Well, 0 cubed is 0. 0 times 0 times 0. And then plus 4 gives us 4. Y equals 1 cubed plus 4. So we have 1 times 1 times 1 gives us 1. And then plus 4 gives us 5. Again, when you have these plus 4s and all that, this is where you see the pattern doesn't exist. It really isn't a pattern. Okay, so y equals 2 cubed plus 4. So 2 times 2 times 2 is 8, a positive 8 this time, plus 4 gives us positive 12. Okay, see, pattern's not quite there. Okay, but that's what a cubic function is all about. You're not going to see much of a pattern. Okay, so when you get these plus 4s, I mean. So let's graph it. Negative 2, we go left 2 spaces and down 4. 1, 2, 3, 4. And then we go left 1 space and up 3. 1, 2, 3. Okay. Then we're at 0, positive 4. 1, 2, 3, 4. Then we're... Whoa, what did I... That was not right. Try that again. So we go 0, positive 4, 1, 2, 3, 4. There we go. What was I counting? And then we go over 1, right 1, plus 5. Okay, and then we go over 2, 1, 2, and up 12. So we know the grid ends at 10, and then 11, 12 is about here. So our cubic function is still a little snake, and it's just offset by plus 4. What you're going to notice is this plus 4. Remember, is still the y-intercept. Remember, this is our y-intercept, which we learned. Okay, which we learned a couple sections ago. So this is the y-intercept at plus 4. So the whole cubic function is just offset by 4 spaces. Okay, at plus 4. The one before it didn't have a y-intercept, so it was at the origin. Here's our y-intercept is really 0. It's at the origin. The y-intercept here is at plus 4. Okay, so we're starting to notice some of those attributes of the cubic function. Okay, here's your problem for next class. Take the print screens of all these tables and grids. Make your life easier, please. Okay, and then get this done before class so we can be organized. We can move right through this example. Okay, and we'll get to our workbook page. Okay, so I will see you next class.